Okay, guys, today, inshallah, we're going to continue chapter 4 of section 4 of chapter 4. We're still talking about the metamorphic rocks. So let's make a kind of revision about what we studied in that lesson. So who can remind me what is metamorphic rock? Who can tell me, guys, what is a metamorphic rock? Or what is the origin of a metamorphic rock?
Any rock can.
Okay, yes, Hannah Hamdi can answer.
The origins of a metamorphic rock could be made from any other rock or another metamorphic rock.
Okay, it could make of any one of the three types of metamorphic rock. What are the conditions that could cause the formation of metamorphic rock? Yes,
Heat
Hannah?
and pressure. Uh,
Heat and pressure. So once a rock exposed to extremely heat and pressure, it could change into a metamorphic rock. So we said that once the rock exposed to heat and pressure, what kind of a change that could happen in a rock? That means what changes that happen in the rock causing its transformation into metamorphic rock. Is Judy?
Changes in composition or
Composition, texture,
texture
yes, or
and keratin. No,
structure. Good.
Astra.
So a change in composition, texture, or structure. So that may cause, okay, this to change into a metamorphic rock. Good. Then we said, what are the kind of metamorphism? We said that metamorphism is the process of a changing rock to metamorphic rock. We said there are two types of metamorphism, which are, yes, Lujaina?
Contact and regional.
Contact and regional metamorphism. Excellent. Okay. Which one has great effect on rocks?
Um,
Reem?
okay.
contact metamorphism.
Contact metamorphism. Why contact metamorphism has greater effect than regional metamorphism?
Because rocks is heated by magma, it's more heated by magma.
Excellent. Okay, because rocks which surround magma will be in direct contact with extreme heat and pressure of the magma, so they may change completely. That means the structure, the composition, and the texture will completely change. While in regional metamorphism, it happens because of the pressure of the different layers of the earth over the deep buried rocks. So in that case, the change is that not big like in case of contact metamorphism. Good. Which one could affect larger area? Contact metamorphism or regional metamorphism, guys? Yes, Maya?
Regional.
Regional metamorphism. You see that the effect of the regional metamorphism could expand till kilometers, okay, because of the layers of rocks that could press on the layers down, while contact metamorphism is just for the rocks which surround the magma directly. Good. Then we said that the texture of, the composition of the metamorphic rock changes than the original composition of the original rock, because due to the heat and pressure, some minerals will break down into more stable minerals, or they're gonna form a new minerals to be more stable. And we studied something with index mineral. Who can remind me what is the index mineral? What is the index mineral? New people, others people, Ali, Rashwan, Fadia. Okay, Hannah Drogam, yes.
اللي هو to يعني to see the deep or the temperature
Yep.
the underground يعني ولا
So we said that index mineral is just minerals found in metamorphic rock. That means these minerals are exclusive only for the metamorphic rocks. I can't not find it in sedimentary or igneous rock. And these rocks help, or this kind of rocks, this kind of minerals help to predict or estimate or measure the temperature and the depth which the rock formed at, because this kind of rocks, or this kind of minerals, or these index minerals, require specific temperature and specific pressure and depth to be formed at. So like this, we said, like as you can see in the picture in front of you, chlorite, muscovite, mica, and the garnet, they have specific temperatures and depths that they are formed at. So once we find a metamorphic rock that include one of these minerals, I could predict what is the depth and what the temperature in which this rock is formed. You get this, guys?
Yes.
Then we said that also during metamorphism, the texture of the metamorphic rock is gonna be changing, and we said that texture of metamorphic rock differ than the texture of other rocks, because we usually in sedimentary and igneous rock classify texture into fine-grained and coarse-grained, but in case of metamorphic rock we have a different classification. So what are the two types of texture of metamorphic rock?
Coarse grain or
Yeah,
fine grain?
yeah. So Fadia, yes, what are you saying?
Coarse grain, then this one, fine grain.
No, actually, fine grain and coarse grain, that's for sedimentary and igneous rock, but in metamorphic rock we have different things. What are? Yes, Maya?
Foliated and non-foliated.
Yes, we have foliated rocks or non-foliated rocks. So metamorphic rock, according to the texture, could be classified into foliated and non-foliated. So yesterday we just studied the foliated metamorphic rock. Who can remind me what is a foliated metamorphic rock, or what mean by foliated texture? Yes, Lorena?
When minerals are arranged in planes or bands.
Excellent. Okay, so we said that metamorphic rock, if the minerals which already form this rock are arranged, have a certain pattern in planes or in bundles, we call that a foliated metamorphic rock. And we said that it depends on the conditions which the rock is going to be formed at. Okay, and here we get the example as you can find in front of you, that sedimentary rock like shale is a sedimentary rock. Once it's exposed to slightly heat and pressure, that means not too extreme heat and pressure, it's going to change into a metamorphic cold slate, and we could observe that the minerals are arranged in plates, okay, or planes, as you can see here. If it keep, okay, exposing to heat and pressure, also the structure of the slate will change to be another metamorphic rock, which is phyllite, and you can find it still also arranged in planes. And if it exposed to more extreme and heat pressure, so you could find it's change into schist, another metamorphic rock, and you can observe some bundles and some planes here, so still foliated and so on until it formed the gneiss, okay, in the highly extreme pressure and temperature. So that about the foliated metamorphic rock. Today, inshallah, we're going to talk about the last part in our lesson. We took in the other type of texture, which is non-foliated metamorphic rock. So we said that non-foliated metamorphic rock, we could expect that it's completely the opposite of foliated metamorphic rock, in which the minerals will not be arranged. That means here I can't find planes or I can't find bundles. Minerals just stick to each other randomly. They don't have a fixed pattern. So we call this non-foliated rocks. So actually non-foliated rocks, they usually made of one or few number of minerals. That's why we cannot feel the difference of arrangement, or just find them they mix together without certain arrangement. In that case, once this mineral is exposed to extreme temperature and temperature, they are gonna, or the minerals, they are gonna combine together, or they are gonna fuse together to make a new combination, and we call this process recrystallization. Let's take an example. Example here we have some minerals like quartzite. Quartzite actually, it's one of the, this one, as you can hear, that's quartzite. It's a metamorphic rock. If you look to this one, or the marble here, could you observe any planes or bundles, guys? Could you see arrangement of minerals, or you could find any features found in this one? No.
No.
So it's non-foliated. So the idea how quartzite is formed, it's quartzite, so we could expect it's made up of
Quartz.
quartz. Good. So actually, quartzite, it's a metamorphic rock that made of quartz sandstone. That means it's already made of quartz and sand grains. Both already are sedimentary. Okay, once they were sedimentary rock, but once quartz and sand they exposed to heat and pressure, the spaces between the quartz and sand disappear and they start to fuse. Okay, that means merge together, and they make a process of recrystallization, forming the crystals of quartzite. So in that case, I cannot differentiate between the minerals found inside that rock. That's why appear non-foliated. Is it clear, guys, here?
Yes.
Yep. In the also the same happen once the limestone. Okay, once we get limestone and the limestone go through metamorphism, that means exposed to highly or extreme temperature and pressure, we find that the quartz, okay, in the limestone and the calcite, they will merge and they will, okay, combine together to forming marble. Okay.
Can you repeat, please?
Again, which part? This part from the beginning, the two examples.
Yes.
Okay, so here, guys, the idea of non-foliated metamorphic rock, that they are rocks. Their minerals are not arranged in fixed pattern. They just randomly combine to each other, or they randomly mix it to each other. So in that case here, I cannot find planes or bundles like in case of foliated metamorphic rock. So how does it happen, or why? Let's take an example. We have two non-foliated metamorphic rock like quartzite and marble. Quartzite, actually, from its word, I could predict it's made of quartz. Yes, it's made of quartz sandstone. Okay, so we know that sandstone is a sedimentary rock and quartz is a mineral. Okay, so once the quartz is mixed with sandstone under high heat and pressure, what happens in that case? They already merge, that spaces between them disappear and they stick to each other, become like one thing. Okay, so we call this process recrystallization. That means instead of separate crystals of quartz and separate crystals of sand, no, they merge together and we get a new crystal, which is a mix between quartz and sandstone. That's make quartzite or form quartzite. Okay, this recrystallization causes quartzite to have different characteristics than, okay, quartz alone or sandstone alone. That means different than the original rock they made up of. Okay, it's become more shiny, it have glittery appearance. Okay, and so on. Okay, so here we find that the other example in limestone. Limestone, I know that limestone is a sedimentary rock. Yep. Okay. What is limestone is made of? As we studied in sedimentary rock, limestone is made of quartz and calcite. So here we are gonna find, once limestone exposed to high temperature and pressure, we're gonna find that they start to recrystallize. That means the minerals will melt and recrystallize in different arrangement. So in that case, we're gonna find that the calcite crystals in the marble are gonna be larger than normal calcite. Okay, and we are gonna find also that the crystals of quartz, okay, gonna change. So overall, they will form a new metamorphic rock, which is the marble. Okay, guys,
Okay, Mister.
is
Okay.
it clear? Are you sure?
Yes, yes.
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 Okay. So here like this, that's the difference between foliated and non-foliated metamorphic rock. The last thing which we're going to talk about in that lesson, as we studied in sedimentary rock and in igneous rock, we said that each rock have some features or have some structures. That, for example, we said in igneous rock, we could find fissures. Okay, we said that small cracks, which the lava comes out to the Earth's surface, it's create a certain shape. So we call this the fissures. Do you remember this, guys?
Yes.
And then we said
Yes.
that sedimentary rock, it could record the movement of water, wind, and like this. So we studied the different features that could found on the sedimentary rock. We said that like the movement of water and sand, and like this. Do you remember this, guys?
Yes.
Okay, so the same here also in the metamorphic rocks. Metamorphic rock also, it could record some things that happen on the Earth's surface or the Earth's crust, okay, within different years, okay, because something called deformations, okay. So deformations, that mean changes or deforms that happen in the rock due to the movement of the rock layers or the environmental conditions that surround the rock. So for example, look at here this image. This image represent folds, okay, that have folds, that mean the layers of the earth surface is already folded or bent. As you can see, could you see this, how the layer are bented? Do you see how they are bent?
Yes.
Yes, okay. So here like this, that means, or that represent that there is a kind of movement of these tectonic plates, or the movement of the Earth's crust cause the rocks to be bent, okay, or to be curved like that. So I like this, I could expect that mean in the past, from millions years ago, for example, they were just flat layers, and due to uplift movement, it caused, okay, these layers to bend like this, okay. Okay, guys, is it clear?
Yes.
Yeah,
Yes.
okay.
Yes.
So here like this, as you can see, I need someone to read this paragraph, guys. Let's find someone could read this paragraph. Yes, Hannah?
Metamorphic rock structures. Like igneous and sedimentary rock, metamorphic rock also has features that tell you about its history. In metamorphic rocks, these features are caused by deformation. Deformation is a change in the shape of a rock caused by a force placed on it. These forces may cause a rock to be squeezed or stretched. The folds or bends in metamorphic rock are structures that indicate that a rock has been deformed. Some folds are not visible to the naked eye, but as shown in Figure 7, some folds may be kilometers or even hundreds of kilometers in size.
Yeah. So here, of course, guys, that's a very far image that represents how the rock look like. But if you imagine that you are standing in that mountain, of course, you will not observe this bending because it's really too huge. You expand for many kilometers, okay? And of course, this huge deformation happened because a huge force that caused these rocks to be bent like this. Okay, guys? Is it clear?
Yes, you must.
Do you have
Yes.
any question regarding to this lesson, guys?
No, thank you.
Okay, so like this,
No,
we
thank you.
already finished our lesson and we finished the total things about the rocks and the rock cycle minerals and like this. So now you know a lot of information about rocks and minerals, and that good. Okay, so your homework for today is you are gonna answer the section review. This section review will be your homework. Okay, so I'm gonna check it with you tomorrow, inshallah. If you have any question, just ask next session. Just study this lesson very well from your textbook. The underline or mark the parts that you can understand it and ask next time, inshallah. Do you have any
So,
question?
do we need to send it through WhatsApp?
No, just answer it. Okay, I'm gonna check it tomorrow, inshallah. Okay.
And you will not send it?
You can just send it. Okay, you can just send it through the WhatsApp on the group. Yeah. Okay.
Okay.
Just take a photo and send it. Okay.
Okay.
Yep.
Okay.
Thank you, guys. Okay. But just send it on the group, not private, guys. Okay.
Okay.
Okay. Thank you.